From your spam filter to the tech in self-driving cars, machine learning is pretty much everywhere. But have you ever stopped to wonder how a machine actually learns? It's not magic, I promise. Today we're going to break down the fundamental ways a machine goes from just being code to, well, something that looks a lot like cognition. So let's jump right in.
And that right there is the big question, isn't it? For decades, computers were simple. We told them exactly what to do, step by step. But how do you get a machine to do something you can't program in simple steps? Like, say, recognizing a picture of a cat. The answer is in a completely different way of thinking about instructions.
You see, the old way of programming was a direct command. You type in 2 plus 2, the machine follows the rule, and it spits out 4. Simple. But machine learning adds this fascinating new layer. Instead of just a command, we feed the machine tons and tons of data. And from that data, it builds its own model, kind of like its own understanding of the world, and then it decides what to do. Think of it like this. It's the difference between a cook who can only follow a recipe word for word and a chef who actually understands the ingredients and can start creating brand new dishes.
And this core idea has actually been around for a long time. Way back in 1959, an AI pioneer named Arthur Samuel defined it perfectly as the ability to learn without being explicitly programmed. And that is the absolute key. It's not about a machine following rigid orders anymore. It's about that machine building its own understanding from the data we give it. It learns from experience.
So how does this learning actually happen? Well, this flowchart here is basically our roadmap for today. We're going to focus on the 3 big ones: learning with a teacher, which is called supervised learning, learning all on its own, known as unsupervised learning, and learning through good old trial and error, which is reinforcement learning. We'll also see how they can be mixed together. Let's kick things off with that first one.
Okay, our first method is probably the one that's most like how we humans learn in school. Just imagine a machine that has a dedicated teacher guiding it through every single step. This visual here just breaks it down perfectly. The machine is given this massive data set, right? But it's not just a jumble of raw data. Every single piece has been labeled. It's like we're showing it thousands of animal pictures, and for each one we're pointing and saying, that's an elephant, that one's a camel, and this is a cow. The supervisor is basically giving the machine a complete answer key to study from.
And that brings us to the official term, supervised learning. The model is trained on a labeled data set. That is the most crucial part. Every single input comes with the correct output, so the machine can figure out the relationship between the two.
And believe me, this isn't just some abstract theory. You use supervised learning every single day. That spam filter in your inbox? Yep. It was trained on millions of emails that were already labeled spam or not spam. Algorithms that predict housing prices, figure out if a review is positive or negative, or even help doctors make a diagnosis. They all learned from historical data where the right answers were already known. All right, but what happens when there's no teacher? What if there's no answer key? What if the machine is just thrown into the deep end and told to figure things out for itself?
This image here illustrates that shift so clearly. Notice anything different? The supervisor is gone. Now, the machine just gets this flood of raw, unlabeled data and has no idea what an elephant or a camel is. Its only job is to sift through everything and try to find interesting patterns or groups all on its own.
And this is what we call unsupervised learning. The model has to discover hidden structures in the data without any help. I absolutely love this analogy. It's like someone handed you a box with 1,000 jigsaw puzzle pieces, but threw away the picture on the front. You have to figure out how all the pieces fit together just by looking at their shapes and colors.
So what can you actually do with this? Well, a really common task is something called clustering. The algorithm looks at this messy cloud of data points you see on the left, and just based on their properties, it groups them into these neat, tidy clusters on the right. It's automatically sorting the data into meaningful categories that a human might not have ever spotted. Another really powerful application is finding hidden connections or associations. This is the heart of what's called market basket analysis. An algorithm can chew through millions of shopping carts and discover that, hey, customers who buy peanut butter and bread are also overwhelmingly likely to buy jelly. It uncovers these relationships automatically without ever being told to look for them in the first place. All right, so we've had learning with a teacher and learning on your own. Our third style is a whole different ballgame. This one is all about learning from trial and error, learning from your mistakes. This dog analogy is just perfect. Think of the dog as an agent that's exploring its world. It tries an action. If it's a good action, it gets a reward, a treat.
If it's a bad one, it gets a penalty, or maybe no reward at all. Over thousands and thousands of these little trials, it slowly learns the best strategy to get the most rewards.
And that is reinforcement learning. It's this constant feedback loop. You act, you get feedback, you update your strategy, and you repeat. It's not about being told the single right answer like in supervised learning. It's about discovering the best path to a goal through pure experimentation.
And this method, wow, it is incredibly powerful. It's how AI systems learn to master incredibly complex games like chess and Go, by literally playing against themselves millions and millions of times. It's also used to train robots how to walk and to fine-tune those recommendation engines that suggest what you should watch or buy next.
Okay, so we've seen learning with a teacher, learning all alone, and learning from mistakes. But what happens when you start to mix these styles? That's the last piece of our puzzle before we wrap this all up. In the real world, getting perfectly labeled data is really expensive and takes a ton of time. So a lot of the time you might have a small, precious amount of labeled data and then just this huge ocean of unlabeled data. This is where semi-supervised learning really shines. It's a hybrid that uses that small labeled set to get a head start, and then it uses that initial knowledge to help it find patterns in the massive unlabeled set. It really is the best of both worlds.
And this table right here brings it all home. Let's just think of it this way. The goal of supervised learning is to predict, and it uses labeled data as its guide. The goal of unsupervised learning is to discover, finding hidden patterns in unlabeled data. And the goal of reinforcement learning is to act, learning the best possible strategy through trial and error. Each one is a totally unique tool, designed for a different kind of problem.
So, there you have it, the fundamental ways the machine actually learns. It's this incredible journey from direct instruction to guided discovery, and finally to this kind of autonomous, goal-driven learning. It really makes you wonder, right? Now that we've taught machines to recognize, to organize, and to strategize, what's the next great lesson we should teach them?